Hi guys, my name is Greg, and today I prepare for you 5 questions from latest radio navigation exams. Topic for today will be radio aids. So let's start with question number 1. According to ICAO Doc 8168, an aircraft is considered established on a VOR approach when within half full-scale deflection, plus minus 5 degrees of the selected radial, 350 feet of the required track, or 1 dot deviation. So for this question, we'll refer to ICAO Doc 8168, Procedures for Air Navigation Services, Aircraft Operations, commonly known as PANS Ops. This document is divided into 3 volumes, and from pilot's point of view, the most important one is volume number 1, Flight Procedures. For this question, we'll be looking at section 5, Approach Procedures, where according to paragraph 334, an aircraft is considered established when within half full-scale deflection for the ILS and VOR, or within plus minus 5 degrees of the required bearing for the NDB. So we can see that correct answer is answer number 1. Now, the problem with this question is that a half-scale deflection for VOR is actually 5 degrees. Therefore, from practical point of view, personally, I do not see anything wrong in answer number 2, plus minus 5 degrees of the selected radial being correct. It seems that for this question, the examiner is looking for a strict definition from document 8168, where plus minus 5 degrees belongs for establishing on a bearing to or from NDB, and half full scale deflection is dedicated for being established on ILS or VOR. Also, fourth answer, 1 dot deviation is partially correct, since the full scale deflection might be represented on some instruments with only 2 dots. So for this kind of ambiguous questions, I would advise you to go for the answer which is the closest to the actual definition from the regulation. So let's select answer number 1, half full scale deflection, and it is the correct one. Now, question number 2. What does QDM mean? Magnetic bearing from the station to the aircraft, true bearing from the aircraft to the station, magnetic bearing from the aircraft to the station, or true bearing from the station to the aircraft. Alright, so all of these are definitions for a certain Q codes. Now, there are a few of them that are worth to remember. So we have Q codes that we use, for example, in altimetry, like QNH, QFE, QFF, or QNE, and Q codes that we use in navigation. 4 Q codes that we have to know are QDM, QDR, QT, and QUJ. The definitions of all of them you can find in the answer in this question. So, the first definition, magnetic bearing from the station to the aircraft is QDR. True bearing from the aircraft to the station is QUJ. The third one, magnetic bearing from the aircraft to the station, is QDM, and this will be an answer that we are looking for. And the last one will be a QT, true bearing from the station to the aircraft. So, yes, and answer number 3 is a correct one. Now, going to question number 3. As part of the safeguarding ILS signals during ILS operations, the ILS critical area is, and we have 4 possible options. So, all ILS antennas, either for localizer or glide path, have to be protected from interference. Any vehicle can block or disturb part of the signal, causing scalloping or a beam bend. So to protect the ILS signal, 2 areas are established: ILS sensitive area and ILS critical area. ILS critical area is a defined area around localizer and glide path antennas where all vehicles are strictly forbidden during all ILS operations. Now, ILS sensitive area is an area beyond ILS critical area where movement of vehicles and aircraft is controlled during ILS Cat 2 and 3 low visibility operations. Now, for these operations, a cat 2 or 3 holding points are established, usually well before standard holding points. So, going back to the definitions, the correct one will be in answer number 4. The IS critical area is an area of defined dimensions around the localizer and glide path antennas where vehicles, including aircraft, are excluded during all IS operations. And answer number 4 is correct. Now, question number 4. Which one of the statements below regarding DME is correct? All right, this one is actually a rather straightforward question. I've chosen it because you can learn here a lot going through all the answers. So let's go one by one. The first one, the indicated distance is the ground distance measured from the aircraft's projected position on the ground to the DME ground installation. Oh, that's not true, because the indicated distance is a slant wedge from the aircraft to the DME. Slant wedge is an actual distance in a straight line in the air and not a projection on the ground. That means that, for example, if we are flying exactly over the DME station at, let's say, 6,000 feet altitude, the indication of the DME distance will be roughly 1 nautical mile, since 1 nautical mile is about 6,076 feet. So this answer is incorrect. The second one, the DME operating frequencies are in the UHF band. Well, yes, that's correct, and it's a quite straightforward answer. Remember only one thing, that whenever we have DME coupled with other navigate like IDES or VOR, we do not need to set the UHF frequency into the receiver. It's being done automatically. Now let's check the last two answers. Answer number 3, 2 lines of position obtained from 2 different DMEs given unambiguous fix. Okay, line of position is a line to the station or around the station with a possible location of the target. So for DME, it will be a circle with a specific slant edge as a reuse. If we have indication that we are, let's say, 10 DME from the station, it means that we are somewhere on a circle within 10 nautical miles slant range from this DME, but it can be anywhere on that circle. Now, even if we had a second DME available for our position fixing, it would still create 2 possible fixes, since 2 position lines in the shape of a circle would have 2 intersections. And the last one, the DME ground station is always co-located with a VOR station. And this one is also incorrect. Please remember that DME can be a standalone station. It can be also co-located with an ILS, or rather rarely, but still with an NDB. So, as I mentioned before, answer number 2 is correct. Right, last question. Question number 5. The principle of operation of an ILS localizer transmitter is based on 2 overlapping lobes that are transmitted on the same or different frequencies and carry different modulation frequencies or phases. So, ILS localizer is transmitting in a VHF band between 108.000 and 111.950 MHz. And only frequencies with odd number after decimal is available for the localizer. The frequencies with even numbers are after decimals are reserved for VORs. Now, both lobes are transmitted at the same carrier frequency, but each one is amplitude modulated. The right lobe at 150 Hz and the left one at 90 Hz. So, when an aircraft is perfect on a localizer, a receiver receives an equal amount of modulation. Therefore, the so-called difference in depth of modulation, DDM, is 0, and CDI shows no deflection. For example, now, if there is more right modulation sensed, the CDI will deflect to the left, indicating that our position is to the right of the localizer, and we have to correct the left. So, the correct answer is answer number 1. Lobes are transmitted on the same frequencies and carry different modulation frequencies. And this one is also correct. Alright guys, that's all for today. I hope you enjoyed, and hopefully see you next time.